and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's Linode, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. This episode is brought to you by Acryl Data, the company behind DataHub, the leading developer-friendly data catalog for the modern data stack. Open source DataHub is running in production at several companies like Peloton, Optum, Udemy, Zynga, and others. Acryl Data provides DataHub as an easy-to-consume SaaS product, which has been adopted by several companies. Sign up for the SaaS today at dataengineeringpodcast.com/Acryl. That's ACRYL. Your host is Tobias Macey, and today I'm interviewing Andy Dang about powering observability of AI systems with the WhyLogs data logging library and his work at WhyLabs to add some additional context on top of that. So, Andy, can you start by introducing yourself?
Hi, my name is Andy Dang. I'm the head of engineering and a co-founder at WhyLabs. Before WhyLabs, I spent 6 years at Amazon working on big data, data engineering, and real-time systems and machine learning platform, and also AWS SageMaker before this. Currently, I'm in charge of a lot of engineering decisions and architecture and thinking about how to make data observability as accessible as possible to not just WhyLabs customers, but to the general data flow from both data engineering and machine learning.
And do you remember how you first got involved working in the area of data?
Yes, I actually started working at Amazon building services first. So it was a lot of REST service building. And as part of that, I was working on advertising. And that's when I got introduced to, first of all, machine learning and then data science, because we had a data engineering. Because we had to deal with massive amount of data. And this was just at the cusp of Apache Spark becoming a popular tool. So I got to see the transition from a very legacy system, and this system was even not an Apache Hadoop file system that was fancy back then. But then that transition from the jump from a very legacy system to a very modern system using Apache Spark. And I really enjoyed that journey and ended up building a lot of pipelines and figuring out how to make those. Was also before Airflow as well. So you had to figure out how to stitch them together and monitor them and deal with failure. So that was a lot of lessons there, getting to work with really smart people hands-on.
Now that has led you on this path that is brought you to where you're currently working at WhyLabs, building the WhyLogs library and some of the additional capabilities on top of that. And I'm wondering if you can talk through what it is that you're building there and some of the story behind how you ended up focusing on this particular problem domain and why it is that that's where you want to spend your time and energy.
Yeah, so as part of working with Spark and big data pipelines at Amazon, one of the things I learned was that there's a massive gap in how data scientists can access these big data systems. So that's why I transitioned into machine learning a little bit, where I wasn't working in machine learning per se, but trying to bridge the gap between machine learning and big data and building tools around that, like connectors to data sources and making it easy and less friction for scientists to access Spark environment. And as part of that team, I met Alyssa and my CEO and Sam, the CPO, and that's where we met. And we had a lot of fun building this kind of end-to-end product where it involves front-end, middle-tier, user experience, back-end, massive scaling, and dealing both data problem where you have the scaling issues and all this kind of hardware and infrastructure, and then machine learning, which has a kind of different set of challenges like libraries, Python dependencies, and workflow and dependency management. And this kind of set of complex challenges really got us excited. And when we left Amazon, all of us thought about the kind of problems we wanted to solve. And we want to be in the middle of the road between data and machine learning and figuring out how to solve problems from not just the technical angle, but really driving it from the user experience around how humans interact with this system. And that kind of like another thing that we had the aspiration to build while I was thinking about being the interface between the machine and machine learning technologies and humans and data technology as well, and making it really accessible to not just the technical person who's executing it, but across different stakeholders and trying to work out these both from the technological challenges and user experience. Yeah, that's why Lab got started. And then we narrowed down into the area of observability and monitoring for machine learning. That's where we ended up where we are today. But we didn't start right there. We explored a few ideas initially as well.
And there are a few different avenues that I'd like to explore here. So, one thing is the context of data observability, which is a very active space right now with a lot of different approaches people are taking. Another is the juxtapositions of data logging as a particular activity as compared to just logging for diagnostic and debugging purposes in software systems. And then the overall space of observability in the context of AI systems and how that maybe differs from the analytical data observability that a lot of people are focused on right now with the questions of, what is the lineage? How is that going to impact this dashboard that is powering decision making at the C-suite kind of thing? And so I guess for probably the shortest path first, maybe digging into the juxtaposition of data logging as a differentiated capability from regular software application level logging and some of the context and semantics that brings with it.
Yes, I think data logging is definitely something. When we started, we looked at the landscape. We examined it through by thinking about our experience and then talking to hundreds of practitioners here in Seattle. And one of the things that kind of came out of it is that the data logging is a second-rate afterthought for a lot of both engineering and data scientists. And the reason being that it's extremely hard to log data. And to be fair, it's not really a well-defined term at the moment because very few people are doing it. Typically, when you talk about data logging in the context of data, people often think about storing a subset or a replica of the data in some other system to do something like monitoring and observing it. And that's the kind of traditional thinking. But one of the things when I worked with Amazon, I learned is that you can't do that, especially, first of all, when you deal with massive volume of data. And the second thing is that when I work in that, we actually had these challenges of we were not allowed to store these individual data points because of contractual agreements, like Facebook ads data. You cannot store for X amount of time. Over that, then you have to delete the data. So, of course, now you know GDPR and all various legal compliance requirements. So duplicating data to log it, like operational purpose is just wrong at so many levels, even when you do sampling. So that's something from the kind of first principle that we concluded. And then we try to really think about software logging and thinking about telemetry, and software logging just provide a very kind of high level overview of the insights of the software. I mean, it's dependent on the user to log it in a way, and there's an art to how much you log and what kind of granularity you log your information. And that's a DevOps workflow. And that's something we want to bring to the data world, is the ability as you stream through these massive data sets and through this kind of real-time data stream, you can collect certain information to give you not necessarily the full picture, but some insights about the data. An example is just the count, very common in many monitoring systems, is monitoring the count of the data. That's a great start for data logging because it does give you some sense about the stability of your data stream or data sources. Obviously, there's a lot more technique, and we kind of expanded from there and built on that kind of idea of how do we build this, using some very old concepts or very well-founded concept to perform these tasks. And we're not reinventing the wheel here. We're just trying to apply existing concepts around using from information retrieval world, actually, to really make it lightweight, make it easy to log data and doesn't break the bank and doesn't cause performance issues. So that's pretty much from my technical point of view, that's where I kind of headed down towards the path when trying to solve the question of how do we solve this data logging challenge.
Another aspect of this is the difference between what you're doing with WhyLogs and this concept of data logging and the overall approach of capturing summary statistics for being able to understand, what are the count of columns, what are the distributions for values within this particular data set, and some of the ways that you are maybe either augmenting or going a different direction than this approach of summary statistics for a purpose of understanding what is the context of the data and using that for either data quality checks, for just making sure that you don't all of a sudden have an order of magnitude more rows or fewer rows, and also for the sort of data exploration aspect for understanding the context of the data there.
The output of WhyLogs are similar. It does try to produce summary statistics. It has a lot of overlap with the output of these kind of other things. For example, I can think of is like pandas profiling. It spits out very similar kind of output statistics about unique values, categorical features, etc., etc. So the output is the same. It's the way we execute WhyLogs that is uniquely different. We don't make any assumption about the underlying technology. In particular, what that means that we have specific technology in implementation, but WhyLogs can work with a wide range of technology. An example is that, starting with pandas, that's where a lot of this small library kind of local workflow that you start with. But then you're scaling up a bit, you get Apache Spark. Again, that is massive scale, but still you have a nice interface. And then we keep going and you end up with things like Apache Kafka, where data is in the real time with partitions and dealing with consumers and a model and whatnot. And WhyLogs has Kafka integration, for example, because it kind of abstracts away the underlying data storage. It treats the data as a stream as well as a batch. It has two modes. And the trick for that is, to be honest, just modeling the streaming world in micro batches. And that allows WhyLogs to really still operate when dealing with streaming data sources. And then you go to the really original source is where you, for example, run your services, where in an API world, then that's where WhyLogs can also handle individual API calls as well by logging those things. We're really trying to the most common building block for this, for the interface for these operations. Of course, there's a lot of optimization underneath the hood to make it work with different data sources, like if it's columnar, for example, Spark is a common example. We have really specific optimizations for Spark to really take advantage of Spark power and things like UDFs. But then, if users don't have that, they're not blocked from using us. So that's something that is the unique differentiation aspect from WhyLogs to the other system. And another thing is that from mental concept, WhyLogs separate the problem of statistics collection. So that's where you do this kind of some fingerprinting. We try to basically collect what we call data sketches, which is just some very, you can imagine them a bunch of bitmaps putting together so we can estimate things like uniqueness of the data stream or frequent items and etc. So WhyLogs collect these merge, and they are all mergeable, by the way. So in a way, very map reducible, very Spark friendly, very kind of distributed system friendly. So WhyLogs allow you to collect these mergeable lightweight objects, and you can store them in your local store. And then you can run the analysis after the fact. So we did really decouple the problem of, and this is similar to DevOps. You collect metrics and telemetry and log in one place, and then you have another system that monitors these changes like Grafana or Datadog. That's the exact model that WhyLogs get the inspiration from. So the data might have disappeared in a way. You might not have that data anymore. You only have the WhyLogs profiles left in your system, which you can store because it doesn't really contain individual data points. And then you can still run things like what you described, summary statistics analysis on top of that. And because they're mergeable, so you can do slice and dice, like by hour, by day, it's up to you. But that's the power of WhyLogs is, and it's actually really powerful because a lot of the time you don't think about the exact analysis you're running. until you see some problem. For example, it's like it tends to work really well with the interactive analysis workflow. And since it doesn't scan through the data, it doesn't require a massive processing backend, it's super fast to really run through a whole year of analysis, for example.
As far as the core use cases that you're looking to power with WhyLogs and the WhyLabs product on top of it, I'm wondering if you can dig into that and maybe add some compare and contrast to some of the other systems folks might be familiar with, such as Great Expectations in the open source space, or Monte Carlo, Soda Data, Datafold, et cetera, and just the overall space of data observability for the data engineering focus and what you're building.
So with WhyLogs, our aim is to be the standard for data logging. I believe that's the only library in the world of open source at the moment that does both for real-time system and for streaming system. So that's WhyLogs' goal, is really to provide, first of all, the ability to log and to collect these log objects, to manage them. We're building a lot of APIs and utilities on top of this. And then the tools to run analysis, like building Jupyter notebooks, building reports, generating alerts, and generating what we call constraints. Those are the kind of first part of WhyLogs, and it overlaps somewhat with expectation. Only one part is where we handle constraints. So WhyLogs can also, while it scans to the data, it also check for constraints from both individual data points, or you can also run a constraint validation against the final WhyLogs output. So with individual data point, you need to know the kind of constraints you want in advance. But once you have a profile, you can run other various constraints. And because we have the summary statistics, we can also suggest the constraints for WhyLogs. And this is the difference between WhyLogs and Great Expectation. Great Expectation require you to have all the data available in some system that you can query into local interface. And what that means is that either run it on Pandas or it's backed by Spark SQL underneath the hood. And that means that it's limited to tabular data and Pandas data. WhyLogs is not limited to that, because the way WhyLogs work is that you can hook in your own transformation as well. So it actually can work with not just tabular data, it also work with things like images and video. One of the examples, we have a blog post about this, is detecting the RGB channels in images and using that to monitor the distribution drift, because a very common pattern is when you change the camera model and kind of the lighting just a little bit off, even though the lighting condition is the same and the model behaves a little bit differently, and people want to detect that. Or sometimes if you take a different picture, the distribution of these things change quite significantly as well. So that's one thing of the open source part. When we look at WhyLogs, what the differentiation it is compared to Great Expectation, we focus a lot more on real-time system as well. Great Expectation does not support that because it requires data to be fully available. And our focus is a lot on not just Apache Spark, but other distributed systems and also data types, like the complex data types. When it comes to the platform, now this is where I guess the comparison with Monte Carlo and Soda Data is more kind of like direct one-to-one, because these are platforms, they have solutions. They don't necessarily just a library. They don't have an open source library. So when it comes to the platform, WhyLabs focuses really optimizing towards now is to really building first-class monitoring for machine learning first and foremost. So what we do is we focusing on really machine learning specific problems like data drifts and model performance challenges and explainability, rather than optimizing for the workflow of SQL data warehouse management. Of course, we can do both. We have customers who use WhyLabs to monitor both, because the outcome of your data pipeline is your machine learning model. So it's not a decoupled problem. We don't really, I wouldn't say compete, but I would say that we target a very subset of problems that is different from what Monte Carlo or Soda Data target. What they target is really like SQL-based system where you can run SQL queries against and collect these summary statistics using SQL. What we target is more like Delta Lake and real-time system with complex data types. And then typically the systems affects machine learning models and business KPIs. So it's a bit of a kind of market segmentation, I guess, but also a technology segmentation, because when people start running things in real time and in production, These tools don't really monitor them unless those customers also have a system to vend data back to a SQL database, which also that pipeline tend to take much longer than monitoring it right there in the container, for example.
RudderStack helps you build a customer data platform on your warehouse or data lake. Instead of trapping data in a black box, they enable you to easily collect customer data from the entire stack and build an identity graph on your warehouse, giving you full visibility and control. Their SDKs make event streaming from any app or website easy, and their state-of-the-art reverse ETL pipelines enable you to send enriched data to any cloud tool. Sign up for free, or just get the free t-shirt for being a listener of the Data Engineering Podcast at dataengineeringpodcast.com/rudder. In terms of the actual implementation of WhyLogs and the structure of how you have approached designing it to be able to work across these various contexts, I'm wondering if you can dig into the design and implementation.
Kind of first-class metrics that we have in WhyLogs are all mergeable. So they're meant to be run in a distributed environment. So that's the first thing we try to locate. And therefore, we identify various data structures and algorithms that allow you to do this. Specifically, we use HLL, for example, hyperlog, which is a bunch of bitmaps, by the way. It's nothing fancy. Once you need the hood, although the maps are fancy, it's not the data structure that is fancy. This is used in Google BigQuery, for example, or Postgres to estimate the uniqueness cardinality of a column. What that means is that we ended up going with an open source library called Apache Data Sketches. That library was built by Yahoo for the purpose of weblog analysis, but it has this library built in from both Java and Python, C++ specifically for Python, so very performant and very lightweight. And it works in both world of data engineering and data science, because Java is really the language of big data pipelines these days. Python and C++, Python specifically, is the interface for data science. So it kind of sits in between very nicely. And we add a lot on top of that is the ability to hook into various data sources. We really optimize on kind of like automatic schema detection, a real-time workflow, and API for real-time versus batch workflows, and thinking about how to extend it, like supporting extensibility. Just one thing to call out is that we actually have learned tons through the last 2 years of building WhyLogs and interacting with the open source community. So we are rebuilding it now to make it even more extensible, because we have people who realize the value of WhyLogs and they want to use it not only for machine learning monitoring, but they also want to add things I never thought that they would add, like application performance into these sketches, because it can handle anything that is numerical, it can handle fine. So while they use things like Datadog to monitor their models or their system, for example, they also want to have some kind of the coupling of like the data fingerprints alongside with the application performance fingerprints. And it's definitely an interesting thought. I didn't know about that before talking to various folks. But yeah, we really optimize based on this kind of thinking about what the friction in data science workflow and reduce the configuration. Because one thing I guess I didn't mention is that in data monitoring, you have massive number of features and columns, and therefore you don't want to configure each of them from both the data logging perspective and then the data monitoring as well. Like once you collect these, you want to quickly run analysis, and we want to make sure that you can run analysis to thousands of features without having to like set 2,000 parameters in the monitor. So we want to build in like smart defaults and really optimize for different workflows. So, and again, these are actually workflow specific. If you have a kind of data warehouse, you want to monitor against a Kafka stream. That's a bit different from monitoring a machine learning model with NLP in it. And we really think about how to optimize different recipes for different use cases here. But the key thing here is like you start off with a very fundamental kind of composable core to start with.
And given the fact that you do have implementations and bindings for both Python and Java runtimes, I'm wondering how you approach maintenance of feature parity across those environments, as well as being idiomatic and keeping them in step with each other so that you don't end up tilting too far in favor of one or the other language ecosystem.
The reality is that Python just has way more support for data types. Images, you can't do the same thing in Java. But on the other hand, Java has things like Apache Spark integration that, for example, even now Spark integration in Python is there. But once you look into the API, it's actually backed by the Java implementation. We just call the Java UDF underneath. It takes a bit of a trick, but to make it natural, like this. So the two ecosystems do complement each other. They're not against each other. It's definitely a challenge for us to maintain the feature parity. And one of the things we haven't not really invested in is to provide feature parity. And this is, I guess, also the reality is that we have very different personas in the two worlds when it comes to users, the data scientists alone, but the MLEs and the data science users in the Python world, they have this, well, Python is very flexible, like untyped. They have this kind of like really like maximizing flexibility mindset. Whereas in the Java world, people want nukes and hooks to control performance. They want performance optimization that they can really fine tune. And unfortunately, they don't really, it's really hard to find a common API that support both of these. And we want to minimize the configuration as much as possible. So this is a journey we're still exploring and learning through various customers. We actually have learned a few things about this sort of schema and then kind of like dealing with massive number of features in columns. I think there's still going to be a lot of differences between the ecosystem because we want to make sure that it makes sense for the scientists as well as makes sense for the data engineers. And sometimes what makes sense for one doesn't make sense for the other. And we have to make sure that our API is designed with that in mind.
As far as the overall ideas that you had going into building WhyLogs and starting to explore this space, I'm wondering what are some of the ways that the goals and design of the system have changed or evolved since you started working on it, and some of the ways that your ideas and approach have shifted?
So one of the first thing we started with WhyLabs is, well, every startup goes a crawl, walk, and run, right? We started with really no configuration. Like you just send in all sort of profiles who will detect the smart defaults for you, and we run analysis and generate anomalies. And then, or alerts. And then we realized that, wait a minute, people do need configurations because each of these data problem have their own characteristic. Different to monitor a retail kind of seasonal data set versus monitoring a model kind of training pipeline that runs with relatively stable data or day over day or fraud detection model. So that's one thing that we crawl by just like building with no configuration, but adding a lot of important like algorithms on top of that to really like solve different specific business problems. One, we really optimized towards data science flow initially with like detecting drips, which is a hard problem when you have massive data scale. So drift analysis, we really optimized on that initially. We found a bunch of algorithms that work with WhyLogs. They're actually now in the open source. Part of them are in the open source implementation now. And then optimizing for the data science workflow. So how to make it easy to monitor various things. And then we realized we need to add knobs to this. And we introduced a configuration language, but it's quite complex to write. So our interface only allows you to tune like 5-6 knobs and with parameters, of course. But our main UI is optimized to really like make it easy. So you don't have to deal with the complex configuration language behind the scene. Of course, you can go in and call the API with using this particular JSON schema, and it will work. But the challenge is that it is complex and it is big, and it wasn't really designed with user experience in mind when it comes to that configuration language. So that's the second part where we're kind of walking, but we're kind of like crawling in the sense of enabling the configuration language. So it's very easy to user to come in and start monitoring. Like they don't even have to touch anything. We enable all these smart defaults by default based on the use case. And then finally, nowadays, we are actually revisiting that. We have revisited that decision and we are introducing a lot more knobs and tunes and redesign the language so that we can build not just an API on top of that is easy to use, but also a kind of user experience workflow that allows you to set up this configuration without having to deal with that. And by the way, once you start monitor both machine learning and data science, the workflow gets extremely complicated because an example is that the cadence of things are different in the two worlds. Like the data engineering pipeline tend to move a lot slower than the machine learning real-time prediction pipeline. They just have a kind of different set of expectations. And we have to capture all these knobs into our configuration and our user interface and make sure that we're not trying to solve everything at once, but making sure that we can at least solve some of the fundamental problems like data lateness, latency, etc., into the user workflow and allow users all this sort of control. So it's been a fun journey, but very challenging. Something I never thought, like a lot of things, even though I work with data pipeline, but you kind of like have this split mentality when you think about machine learning versus data pipeline, and you don't realize that once they cross path, the kind of like the number of problems just multiplies by the same dimensions. Like, yeah, it's a bit crazy.
And as far as actually adopting and integrating WhyLogs, I'm wondering if you can talk through that process of starting with either a greenfield or an existing code base and starting to add the instrumentation and log capture and figuring out where to put it, what systems you need to put WhyLogs into to be able to get the full visibility across the workflows, and just that overall process of getting started with it and starting to capture that information and do some debugging and alerting on it.
So typically people start with WhyLogs with a pandas data frame. Like a lot of people are using Jupyter Notebook. We really optimize for that flow because that's pretty much the one-on-one experience these days with all sort of notebooks experience across the board, from Databricks to kind of like SQL-based systems. What we ended up doing is a few lines of code for you to get started with WhyLogs. The key thing here is for you to have either a pandas data frame or a Spark data frame. And with Spark, you do need a bit more configuration, like hooking the library into the Spark jar system because it's going to run in distributed mode. But the one-on-one experience is really optimized towards pandas data frames. And you need that, and you need to configure the WhyLog session at the moment to really point it to where you want to store the artifacts and a few other things like, well, I guess at least the pandas one, you only need to point it where it's stored. Actually, you don't need to because it will just store it locally to where you're running the script. So, but that's a configuration that people often like jump into first because they didn't. And then you just need to create a WhyLogs object session, and then you can start logging. It's a very natural API. You don't need to configure a lot of things like schema or expectations or kind of constraints or anything around that. But those are more like advanced API. So a few lines of code is what we are aiming for here. And typically so that's a very basic experience. And if people have things like Airflow or like MLflow, that we have examples to hook into those systems so they can Airflow task, for example, because Airflow takes in a pandas data frame and spit out something. So it can take in a pandas data frame and spit out WhyLogs and store it somewhere. So that kind of mentality, we're working on a lot of examples so you can apply into your existing systems rather than having to do a mental mapping from like, a pandas data frame in a notebook to something else. Feel free to cut a tickets if you see an integration that is not there that you really want, that you feel passionate about. Because they know there are a lot of new orchestration systems out there, by the way.
Absolutely. And for people who are just using WhyLogs purely open source, they don't want to necessarily hook it into WhyLabs. Where would they be aiming to store the outputs of those log events? Is it something that you would just ship to your existing log aggregation system, like your Elasticsearch or your Loki or Grafana? Or is it something where you would need to store it as objects in S3 and have some other different analytical workflow for being able to process them?
That's a good question. Unfortunately, WhyLogs is, because of this hyperlog log, for example, data structure, you cannot ship them directly to, you can, they're just binary. So you can ship them to the storage system, but they cannot understand WhyLogs. That's an unfortunate fact. What WhyLogs open source users do, and by the way, by default, WhyLogs does not talk to WhyLabs. Like you have to wire in a bunch of things before we can talk to the platform because API key. So by default, WhyLogs just runs locally. And you can store them in, typically what we see often is a cloud storage like S3, like just storing them in S3. We've also seen people doing a bit more advanced work, and this is something that we're learning from is Stitchfix. For example, what they're doing with WhyLogs is that they're storing it in columnar data stores using a Postgres database so that you can look up these log objects faster than S3. So that's what they're doing. And what end up happening is that either way, you typically have analysis notebooks and kind of workflows around these log objects. That's the second part is that when you can extract metrics into the other monitoring systems. We're also working on how to integrate WhyLogs into Elasticsearch and other systems, but the information extracted there is pretty complex. We're still working on iterating on like a subset of the signal. An example is WhyLogs collect a KLL sketch, which allows you to build dynamic histograms. And that means that the user need to kind of decide in advance how they want to extract that histogram information. And you lose a lot of abilities if you store it in a static form because you can't do like data drifts without the histogram bins aligning between the baseline and the target, for example. If they don't align, then the algorithm doesn't make sense. So that's something to call out there is you do lose information as you go from WhyLogs to other more JSON-based or kind of numerical-based systems.
The most important piece of any data project is the data itself, which is why it is critical that your data source is high quality. PostHog is your all-in-one product analytics suite including product analysis, user funnels, feature flags, experimentation, and it's open source so you can host it yourself or let them do it for you. You have full control over your data, and their plugin system lets you integrate with all of your other data tools, including data warehouses and SaaS platforms. Give it a try today with their generous free tier at dataengineeringpodcast.com/posthog. The other question that always comes about when you're instrumenting any piece of code is where to put the instrumentation and how much to do it so that you don't end up drowning out the signal for the noise, and just being able to maintain that balance and understanding what are the key points in the data flows or in the logical flows that you need to start to capture this information to be able to actually use it effectively, and just any strategies or heuristics that you have come across as you've been working on building out this system and working with your customers.
Typically, people, in an Airflow step, you might have a lot of transformation in between. And typically, people do put WhyLogs on each of these transformation steps in an Airflow DAG, but it gets, like you said, it gets overwhelming. So the strategy here is to, first of all, really focus on the input and the output first. Like really the beginning and the end of your DAG, that's where you want to put logging in the first place and really do correlation between the two. However, if you have a lot of feature transformations where like new features shows up and then they disappear again, then you really want to put logging when those events happen, because those hidden features in the pipeline might also be a source of bug, and you want visibility, maybe even targeting specifically on these features rather than the ones that already showed up at the beginning and the end. But that's more like a tuning process. The very simple approach is to treat your pipeline as a black box first and foremost and monitor those black boxes. And that's actually true with machine learning model as well, because if you think about a neural network, you have multiple layers, and you can definitely monitor each of these individual layers. Of course, they get expensive because these matrices are massive. WhyLogs can handle it, but it just still doesn't change the fact there's a lot of layers. But then you also just monitor the input of the kind of the model and the output of the model. So very similar kind of fine tuning. It's an art, unfortunately, and there's not really a hard answer, but that's where you start.
The other piece that's always interesting to dig into for any businesses that have an open source component is the question of governance of that project and how you're approaching the long-term sustainability of that open source component, and how you think about the dividing lines between what is part of the open source and what is part of the commercial entity.
That's definitely a thing that we have been learning a lot as well, based on the feedback from open source community as well as other companies who build on top of open source. Our goal is a bit different. So you look things like Elasticsearch, a common thing like Elasticsearch, or I guess the GitLab. The source for the open source is similar to the closed source one, whereas we're kind of like different is that open source is the beginning of the journey, and what we're building is the end of that journey. We're not replicating the open source code internally. We are doing something very different internally because optimizing for real-time storage, and open source really optimizing for logging, for data collection. We are really incentivized to make the open source project work across the board regardless of where you are. So we want to make it friendly to the developer as well as company to really adopt it and embrace it. So that's kind of like the end game is slightly different. We don't want necessarily them to, it's acknowledged that not everyone will convert to WhyLogs customer. Some people will definitely use it for their workflow. For example, Yahoo Japan, they have their own like data center, so they don't even talk to the internet. And obviously, we love that they're using WhyLogs, and that's a kind of success that we love to talk to people about. Is that WhyLogs is not a dependent of WhyLabs. You asked for why we're building it, then we want to make it really easy to ingest these objects and organize them and build like complex workflow analysis that you can definitely build yourself, but at scale. Think about scale of like thousands of, like we have customers with thousands of features, hundreds of models. That gets really expensive to run manual analysis or even build custom analysis. So we want to make it really low-hanging fruit there. But from the open source perspective, well, at the moment, we are still the sole contributor to the WhyLogs open source project, but we have seen people requesting to contribute, and we take active feedback from the community, like Stitfix work really closely with us to provide feedback. So that's from the kind of governance and sustainability. It is for us like big differentiation from the technology point of view. So there's a lot of incentive for the company to make this accessible everywhere. And to be honest, my vision is to make it interoperable with existing DevOps flow, so that you don't necessarily have to use. You can use WhyLogs for collection, but you can still use your existing DevOps tools, for example, for monitoring. And that's a bit a longer term vision because, like I said, they don't map one to one. So you're going to lose something. They can only do a subset of monitoring there. But still, that's going to be valuable to some, less sophisticated users out there who only cares about high level monitoring of their pipeline, for example. And finally, like we are rebuilding WhyLogs as we are speaking at the moment, based on the feedback from the community to make it even more accessible and even more like lower the friction to integrate into various ecosystems. And we will actually work with a lot of open source projects as well to hook WhyLogs into that. So we want to be part of that ecosystem from the synergy perspective. So it's definitely a difficult challenge from the point of view of the company resourcing for it, as in we have a small team. We're building a lot on both sides, from both Java and Python, and requires like matching between the two is the challenge in terms of finding like the people who can work with both. We have those, but then they're not always available on the market. And therefore we would love to figure out how to, get more open source contribution and more like community share. But that's, I guess, is the matter of building the velocity and building the adoption as well on top of that. And I don't know if I have the answer for that at the moment here, but my vision is to really make it an integral part of a lot of data and machine learning technologies.
And then in terms of the sort of business model and the functionality that you're building on top of WhyLogs with the WhyLabs platform, I'm wondering if you can talk through some of that sort of feature matrix and the vision that you have for building a overall sort of end-to-end visibility solution for the machine learning workflow and just the capabilities that you're building there.
We are building a time series data store for this WhyLogs object because it gets interesting when you start collecting these over time in real-time system or in batch systems and then organizing into various views. So that's the first part is building real-time kind of storage. And because these objects are mergeable, we also can build dynamic views on top of these. So you can view hourly versus daily versus weekly, and detecting trends and monitor these, what we call models or data sets in various forms. So that's first part is like really the technology. And the scalability is that we have, we built on top of really scalable technology like Apache Spark and Apache Druid to enable this with very special optimization around WhyLogs workflow, because it's a new data type that is not available in this ecosystem. So we have to build a lot. And so that's the kind of optimization there. And more importantly, the workflow optimization is to think about how we, as a platform, fit into existing customer flow by providing the right monitoring algorithms. So one of the example I have is using, drift detection is a very common pattern that our customers see, and they actually a lot of people don't have things like baseline for their models. So all they care about is really taking the trailing window, for example, and monitor today. And we make it very easy. You don't need to think about building a baseline. You just come in and start sending profiles. And if you send enough profiles and we take enough signal, then we start monitoring. So removing that kind of barrier to monitoring and let people focusing on first data science problem and then just adding a few lines of code. And hopefully we can make it really 0 lines of code as we build a lot of this integration. You can just do it as a configuration, for example. That's the part where we solve is take away that configuration, take away, you ask a DevOps person to configure monitoring for thousands of features. It's going to be challenging. What we're building is holistic aggregate metrics to this. And those are not trivial. It's a complex workflow. And to be honest, that's why we are a SaaS platform, because we need to really iterate fast on this metric as well, because it's an art. It's actually an art of tuning, an art of thinking about what metrics make sense for what problem. And so that's what our value is providing here. And we can really help customer optimize the workflow for as a platform towards their business problem, rather than taking a canned algorithm and apply it non-indiscriminately towards their workflows. You would have to involve scientists to do that. Think about the scientist doesn't have to get involved here. It's the engineer who has to pipe in some logging, and then that's it. And then based on the use cases, they get all this out-of-the-box monitoring, and then the scientist is the end consumer. So free up scientists' effort and time. And finally, it's like I mentioned previously, these workflows are complex because they deal with batch and real-time system, with latency, with data delay. And for people who operate in data engineering world, they know how complex the workflows get. But adding machine learning and kind of model training workflow, it gets messy. So we're really trying to find the kind of sweet spot by talking to a lot of customers and finding the common workflow and optimize for those common workflows, so that hopefully you can solve 90% of the problem out there. We acknowledge that 10% we're probably not going to solve in the first few iterations, and probably have to keep iterate to really hit the last mile there. But we want to optimize for the general workflow first and foremost. So it's a lot of thinking about optimization and remove friction as a platform from this kind of monitoring and analysis workflow when it comes to data quality and machine learning.
As far as the usage of WhyLogs and the work that you've seen people doing with it and some of the applications, I'm wondering what are some of the most interesting or innovative or unexpected ways that you've seen it employed?
I've seen people use WhyLogs to monitor application performance. That is an interesting angle because to them, application performance metrics are just metrics. You do lose out on the kind of granularity because you're using WhyLogs, which assume micro batching underneath the hood. You're not emitting different pipelines, but they actually find values in being able to build histograms over time, 5-minute versus an hour. And they actually collect every 5 minutes, they emit a WhyLogs profile for application performance. Because another thing is that it works well across really large number of dimensions. So keep in mind, if you think about monitoring in Datadog, you get charged per metric. So what they end up doing is that dumping everything into WhyLogs and have us run the analysis for that. That's an interesting flow that I did not anticipate. I was really optimizing towards the data and the data machine learning world.
In your own experience of building the WhyLogs technology and growing the WhyLabs business around that, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I guess the most unexpected lesson I learned was probably, I guess it's a lot around the assumptions around personas of users. We assume certain personas and we optimize towards that. And then somehow customer on board and they have a very different persona. So specifically, if you look at our platform now, is really geared towards the machine learning science persona. But we actually have a good number of data engineering personas who are actual users of the platform. And there's a bit of friction in terms of how these kind of terms are communicated between the two worlds. Because, for example, in data engineering, you call things columns, and in data science, you call them features. And yes, that might be a minor thing, but when you have a data set, that might be a model or versus it's just a traditional data set. They have kind of different hierarchy, different taxonomy. So that's one thing to call out. And that's actually works for, like, it's true from the API perspective to the kind of platform perspective. Like, a lot of assumptions was built around data science workflow. So one thing I learned is that to build escape hatches for the other use cases. This is not just like trying to not to be opinionated from the kind of like the first level operate like kind of workflows, like optimizing for one workflow, because you're a small team being a startup and you really want to make sure that you do well in what you're doing. But then you need to build escape hatches so other people can also hook into that without kind of have to retrofit like we initially. Some of our APIs were not flexible enough. Then people have to kind of like retrofit the data workflow into the ML workflow to model that. And that gets a bit awkward in terms of communication, like the friction of communication over time. That's a lesson I learned, is really like to think about some of the cases where we can allow escape hatches in general from both the open source library perspective and the platform perspective.
For people who are interested in being able to gain some of the visibility and unlock the capabilities that WhyLogs provides, what are some of the cases where maybe it's the wrong choice and they're better suited with just traditional logging or some of the other data observability systems that exist, or a different sort of MLOps platform that they want to run on to gain some of that insight?
For example, WhyLogs is not designed for experiment tracking from the kind of hyperparameter and iterative tracking of building models. That's not what we are. We're aiming to solve the data problem, not model parameter problem. Yes, we can track numbers, but it's the wrong kind of number to track. That's one part. The second part is when you rely on these monitoring signals, when you want to use the kind of numerical data in the platform for running like actual business analysis for your business. WhyLabs is not designed for that. We don't store your raw data, so you can't really pull the individual data points out of that for your own analysis. What we provide is just high-level statistics, and if you really want to use some analysis, some reporting, you really need to go back to the data source, and that means you need your own data store. It does get a bit confusing because sometimes people think that we have the data just from the overall glance, and then they learn that, we actually don't store the data points. They get a bit confused because they were thinking they can use us as a double solution where we can store the data as well. And, the complication of storing data and dealing with all this regulation. So that's an unfortunate fact. And we definitely can do a better job of communicating that, for example.
And as you continue to build and iterate on the WhyLogs project and the WhyLabs product, what are some of the things you have planned for the near to medium term?
So we are releasing a new monitoring workflows in the WhyLabs platform so that user has more power to do things. I did mention the kind of opinionated workflow that we have at the moment with the configuration. The new workflow we redesigned it from scratch for both data science and data engineering workflow. And I think that will be a very interesting angle because it opened up a lot of interesting ways to monitor your data. For example, is that now we don't allow you to have duality in your monitoring, as in you can only monitor hourly or daily or weekly. But with the new monitor, you can do both. And that it's just a different kind of analysis that we run. And also, the new monitor will allow users to have a lot more high-level overview signals about the data rather than looking at individual feature anomalies. We allow you to run analysis across the whole data set and detect changes as a whole rather than as individual features. That's something kind of building on top of the existing mindset. It's not a kind of shift, just making it more configurable, more easier to configure, and then making it easy to really understand the health of your producing data health score and machine learning health scores. So that's the platform side. And the WhyLogs side, we are working on redesigning the API. I mentioned some of the friction around the API. So the new API is going to be 2 lines of code, really, like import something and then log something. Underneath the hood, we're actually hooking into really, like I mentioned, specific technologies, but we're going to optimize the performance to extreme, like using vectorization to maximize performance underneath the hood rather than relying on iteration or pandas operation to do that. We're going to hook into these vectorized operations as a whole. And we're also looking into integrate with Apache Arrow as well, so that you can work with both distributed systems and local memory storage natively without having to copy data between languages. And like if you touch from Python, if you do a Python string into the WhyLogs library at the moment, it requires copying it from Python string to C++ string. And we are working on getting rid of that because Arrow allows you to just hand over the whole string. That's something that I think will be very important for us to hook into a lot more data storage systems, because Arrow seems to be the new standard for data transfer these days, from things like BigQuery to Snowflake. Everyone is doing Arrow. And that'd be very exciting. And of course, the API redesign will make it easier for us to hook WhyLogs into various systems. And we're going to build extensive module to make it work with data flow as well, like data lineage and data flow, like Apache Airflow I mentioned before. But we're also looking at Flight, which is a library from Lyft that also does like data orchestration. It's FLYTE. Yeah, so a lot more integration, a lot more API redesign, and like lower the friction. And hopefully we also clean up the terminology as well so that you can grok it a lot better.
And are there any other aspects of the work that you're doing at WhyLabs or the WhyLogs project itself, or the overall space of being able to generate and analyze the observability information for machine learning and data engineering workflows that we didn't discuss yet that you'd like to cover before we close out the show?
I think that's something to call out is that while WhyLogs is trying to solve a very specific problem around data logging, the general sentiment I see is that as we're moving to a more real-time system, there's not enough discussion about how to think and operate these like Kafka-based systems from the data and quality perspective, from the lineage perspective. It's kind of missing black box at the moment in the sort of like data management landscape, because it's a very hard problem to solve.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
The biggest gap is that when you go from machine learning becoming more adopted, it's a bit of a weird gap to transition from data science, from data engineering world to machine learning world. And that transition is not well defined. A lot of friction at the moment, and everyone is building their own thing with the Frankenstein of technology. And I think I'd be interested to see who's going to solve that problem effectively, from like managing upstream data sources from like Kafka to batch to the machine learning world.
Absolutely. Well, thank you very much for taking the time today to join me and share the work that you're doing at WhyLabs and on the WhyLogs project, and how it's able to help provide at least a portion of that bridge from data engineering to machine learning. So I appreciate all of the time and energy that you and your team are putting into that, and I hope you enjoy the rest of your day.
Yeah, perfect. Thank you. Thank you very much. Really enjoyed the chat.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.